Hello and welcome to this channel. In today's video, I'm going to show you how to solve this projectile motion problem. A daredevil attempts a motorcycle jump across a 60-meter wide canyon. He launches off at a speed or velocity of 30 meters per second at an angle of 25 degrees to the horizontal. Will he make it across the canyon? Let's dive into the solution. This is a projectile motion problem, and in that case, we know that it has both a vertical and horizontal component of the motion. So the first thing we want to do is to draw our free body diagram. With the free body diagram, we begin by placing the motion inside our coordinate system. So in this case, I will use the XY coordinate system. With the XY coordinate system, I have my X-axis to represent the horizontal component of the motion, and then the Y-axis to represent the vertical component of the motion. In this case, I place the origin at this point. So the point of launch of this motorcycle is going to be at the 0 point for both the vertical and the horizontal motion. Now, with this, let's go back to the problem and then see the information we have. So the daredevil attempts a motorcycle jump across a 60-meter wide canyon. So the canyon is 60 meter wide, meaning we can place that width somewhere here, which is 60 meters. So 60 meters wide. With projectile motion, we are going to solve this in a few steps. So now we place the motorcycle here at the point of launch, that is the 0 point, given an initial speed or velocity that makes an angle of 25 degrees to the horizontal. So our initial speed is V0 and the angle it makes with the horizontal is theta. Per projectile motion, after the launch, this motorcycle is going to undergo a vertical motion, in that case along the y-axis, giving it a certain height, whilst traveling a horizontal range, giving it that horizontal part of the motion. In this case, we know the trajectory is going to be parabolic because we have acceleration due to gravity that acts vertically downwards. So g of minus 9.8 meters per second squared. So with that known, the trajectory we know is going to be beyond the canyon along that path. In that case, he makes it beyond it, or he will make it just right at the 60-meter mark. In that case, we know he may either fall backwards or just move forward, or he could go short of that 60-meter mark. So there are three possibilities in this problem, and in each case is either going to land at point A, point B, or point C, and at which point he lands will determine if he makes it or not. Now, this initial launch velocity can be resolved into two components. So we can have the vertical component as well as the horizontal component. And in this case, the vertical component of this initial launch velocity would be the initial vertical velocity of this object, which we call it V0y. So V0y, and then the horizontal component of this speed is going to be V0x. However, we need to find these quantities. To do that, we need to apply trigonometry. In applying trigonometry, we can develop a right triangle because this is a vector that makes an angle with our reference axis, that is the horizontal axis. And then we can resolve this vector into its horizontal component and the vertical component. So applying the trigonometric functions, look at this triangle here. The opposite side is the vertical initial velocity and the adjacent side is the horizontal initial velocity. So applying the sine of theta, which is the opposite side, V0y, divided by the hypotenuse, in this case the V0. So that will give us the initial vertical velocity, V0y equals V0 sine of the angle theta. Similarly, if we use the cosine of the angle, then we are going to get the horizontal component of the initial velocity, V0x, divided by V0. In that case, we have V0x equals V0 cosine of theta. With this known, so the data we have from the problem is given as such. So we are given the range or the width of the canyon, which I'll call it RC, to be 60 meters. We are also given the initial velocity V0 to be 30 meters. We are also given the initial launch angle theta naught or theta to be equal to 25 degrees. Again, the initial vertical position is going to be y0 equals 0, and then the final vertical position is also equal to 0 because it started from the 0 point and then it goes all the way. Either way, it will come back to the 0 point. We are going to make use of that. The important thing to note in this type of motion, however, is that it takes the same time for this object to travel the vertical height and also the horizontal range. All right, so that is very key. And in any projectile motion, always use one of these components of the motion to find the time that can help you solve the other component of the motion, because it is only the time that connects the two. So let's first look at the vertical component of the motion. So for the vertical component of the motion, we use the displacement equation, that is delta y equals 1/2 gt squared plus v naught yt. All right, so this equation is the kinematic equation for the vertical component of the motion. So it relates the vertical displacement of the motion to the time taken for that vertical component of that motion. And we can see that it depends on the initial vertical velocity. So let's look at the solution. So this delta y is simply the y final minus the y initial, and that is equal to 1/2 gt squared plus v naught yt. Now we can see that both the y final and the y initial is 0 because the displacement for this motorcycle is going to be 0, though it will start from 0, go to the maximum height and then back to 0. So there's a net displacement along the vertical direction of 0. So that gives us this side to be equal to 0, and then we have 1/2 gt squared plus v naught yt. Now we can see that this is a quadratic equation which we can simply factorize the time out as t into bracket 1/2 gt plus v naught y, and that is equal to 0. So we have two solutions here. So the solution is going to be either t equals 0 or it's going to be 1/2 gt plus v naught y equals 0. So the t equals 0 is just at time equals 0. So the object is going to be here. So this is not actually useful to us at this point because we already know at time 0 the object is at the origin. However, the second part of this equation is important to us because we are going to use it to find the time it took this daredevil to land on the other side. And with that, we can determine if he can make it across the canyon or not. So this, if we isolate t, is going to be the time equals to v naught y divided by g. And v naught y we know is v naught sine of theta. So v naught sine of theta divided by g. Now with this, we can calculate for the time. So the time is going to be time equals 2 times v naught, which is given as 30 meters per second, times the sine of the angle, which is 25 degrees, divided by g, which is 9.8. So we will find the time to be equal to 2.59 seconds. So it is worth noting that it took this daredevil about 2.59 seconds to make it across or to travel that horizontal range. So now we need to determine that horizontal range and then compare that to the width of the canyon, which is 60 meters in this case, and that will help us know if he did make it across or not. So at this point, we consider the horizontal part of the motion. So with the horizontal part of the motion, the only equation is that the velocity in the horizontal direction is equal to the range traveled divided by the time taken. We know the time, we don't know the range, we know the initial horizontal speed. And the physics here is that the horizontal speed initial is not affected by the gravitational pull. So it remains constant throughout the motion. Therefore, the range that this daredevil is going to travel would be that initial horizontal speed times the time. So the initial horizontal speed in this case is v naught cosine theta times time. and the time we already know it will take him 2.59 seconds to travel that horizontal range. So that range is going to be V0, which again is 30 meters per second, cosine 25 degrees, that's the angle, and then times the time taken for this travel. So we have 2.59 seconds. Evaluating this is going to give us a range of 70.42 meters. Great. So the width of the canyon is 60 meters as given to us in the problem. And then the range traveled by this daredevil is 70.42 meters. So clearly he made it even with additional 10 meters over the canyon. Awesome. All right. So this is the end of this problem. And if you are new to this channel, please subscribe and also share so our colleagues will also get to have these series of interesting solutions to physics problems. And if you are already a subscriber, please like, share, and comment below with what velocity is this daredevil landing on the other side of the canyon. Until then, I will say thank you very much and see you in my next video.